All right, everybody, today we're going to be making a series circuit, meaning you're going to be making the circuit. You're going to pick the numbers and you're going to try to make it work. So there are some things you have to be careful of. You have a big warning here. If you pick too many numbers, if you pick too much stuff, it's not going to work. So remember, there's this whole balancing act of everything that we use that balancing act in order to figure it out. Meaning that Ohm's law is a thing, and then there are rules for series circuits. So if you try to pick too much of the stuff, you're going to end up it's going to end up being wrong. So when we're going to make a series circuit, one of the first things that we have to remember is that the current is the same everywhere. The current is the same everywhere. And so I would like you to pick a 3 resistor circuit. So I'm going to put right here minimum of 3 resistors. Okay, and it could be light bulbs or a combination of light bulbs and resistors, or just light bulbs, right? So, but if we remember that the current is the same everywhere, that means if we pick the current, pick only one. Okay, pick only one current, right? Because if you try to pick like 2 different currents, it's not going to work, right? If you pick I1 as 5 amps and I2 as 2 amps, well, that immediately goes against the rules. So you're going to have to pay attention to those rules as you go through. Here's another one. All right, that the voltage is the sum of all these kinds of things, right? Of each of the voltages, right? So if you pick 3 different volts, right, and then you decide what the battery is, they may not match, right? So you have to be careful about that as well. And then the same is true with resistors. You know that R total, or Req, is R1 plus R2 D2 plus R3. All right, so the same thing. If you try to say a total resistance is something, and then you have chosen these other resistors to be something else, and they don't add up, well then that doesn't balance out. Now here's the other thing, is that we have Ohm's law, right? And that has to go with each one of these subscripts here, whatever those subscripts are. And if you pick too much stuff, then it won't end up balancing out everywhere. Now, the best way that we can do that is to not pick too much stuff. All right. So I would start out, if I was you, and I'm not gonna actually create one here because I want you to try to work this out a little bit. You should pick just one thing, and then fill out that table, right? And see what other piece of information, what is the minimum amount of information that you need in order to solve it, and then see if you can make that work. And you'll find that you really don't need that much information, and then you have to go through and solve it. I would suggest, just as kind of a brief example, is that you write down Ohm's law. Now, I said there's a minimum of 3 resistors of some kind. So I would write down Ohm's law. You know, V total is equal to I total.
That I total, right, is the same everywhere. And then R total. Sweet. Okay.
know that it works with all the Ohm's laws, you know that it works with all the rules, right? Once you have, you found everything, you found all the resistances, you found all the currents, you found all the voltages, you're going to try okay, and it can be just one question for now, or it can be two. Okay, but you are going to try to make a question. You're going to say 3 resistors are lined up in series and blah 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 blah, or a bulb, a resistor, and it's up to you. But you want to now say, now that I know what that sort of minimum amount of information is, like how little information can I give someone and say find this other thing. And so that's ultimately your task, is to make this question. But before you can make this question, you have to make sure that your circuit works. All right, so that's your goal. That's what you're doing today. Have a good weekend. Just kidding. See you tomorrow.